Week 3 is all about arrays. So we're going to get a lot more complicated in what our variables are and what our variables can store. An array is a collection of data values organized in rows and columns. It has a single name. You might also think about it as a matrix of values. But essentially the idea that we can have one single variable, var. Typically to this point it stores a single number like the value of 12, but now it can just store a lot of numbers all at the same time. That is an array. The fundamental unit of data in MATLAB is the array. That's the generic name for pretty much everything we store in variables, at least our class. And it's identified by its size, so the number of rows followed by the number of columns. You might think about it as if you've heard of RC cola, rows then columns. So that's our order, RC. There's more descriptive names for different types of arrays. A scalar is a 1 by 1. It's a single number. This is what we've been working with thus far. We also have vectors. Vectors are a single row or a single column. So a row vector, a single row, it looks like this. Just numbers right next to each other in a single row. It's a 1 by however many values. A column vector is a single column. It looks like this, where we have numbers stacked on top of each other. So it's a R, number of rows by 1. And then a matrix is a more specific word for an array with 2 or more non-singular dimensions. So it has more than two or more rows and 2 or more columns. And essentially in this week, we are just going to create variables. A variable is defined by the data assigned to it. So we are going to assign and modify variables that store arrays. So sometimes they store scalar values, sometimes they store vectors, sometimes they store matrices. In general, brackets are used to create an array. It's not always necessary, but brackets, that's our notation used to create an array variable. So if I say x equals bracket y plus z minus a, and use brackets, some of you guys use brackets for your week 1 homework. Essentially, you are creating a 1 by 1 array. Brackets are used to create arrays. Parentheses are used to group together calculations. So we already know how to create scalars. You just type variable equals whatever the value. We can also create row vectors. There are 3 ways to create row vectors. The first way is by just explicitly typing in each element. So we say variable equals open bracket, type in our numbers. We can separate them by commas or by spaces. This is generally clearer. It helps identify the individual items a little bit more than just spaces. However, you'll probably see me do it this way. And then when we're done, we just type a close bracket. That's not necessarily an approach for all situations, depending on how many numbers you have. If you have 10 numbers, it's not that bad. If you have 100 numbers, that's pretty challenging. We can also use something called the colon operator to create linearly spaced vectors. So if we have a vector that we want to contain like 1, 3, 5, 7, 9, and keep going, that's linearly spaced. There's 2 between each. We can use the colon operator, which looks like this, where we can use brackets. We don't have to. This is one of those instances where we don't have to. But we identify what value we want to start at, what value we want to end at, and what our increment is going to be. So for this vector, I would say 1, 2, wherever I wanted to end, 300. 300 will not be reached. It will stop at 299. It will get as close to, but not go past this ending value. We can also create linearly spaced vectors using linspace. So this creates row vectors. So does the colon operator. This is a function. So the name of the function is linspace. So we type linspace followed by open close parentheses because that's our function syntax. And now we're going to give it a starting value, a stopping value, and the number of digits. So here we give it the increment. Here we give it the number of points. but they do the same thing. They do the same thing. We can also create column vectors by similarly saying variable equals open close brackets, but instead of putting commas or spaces between items, we can put a semicolon between. So note commas stack things on top or put things next to each other. A semicolon is on top of. So this says put E1 on top of E2, on top of E3, etc. on top of En. The other way we create column vectors is by transposing row vectors. So if we transpose, there's two ways to transpose, but transposing takes a row and converts it to a column, essentially flips it, or flips it. Okay. We can use the transpose function, or we can use the transpose operator, which is just a single apostrophe. Okay. You will usually see me do this second one. And then lastly, if we want to create matrices, we are essentially going to combine a bunch of row vectors. We can also combine a bunch of column vectors. We can also combine a bunch of other matrices. Using the same principle that commas puts things next to each other, and semicolons put things on top of each other. So here I have an example where we are stacking a bunch of rows. So here's my first row, then second row, then third row. Semicolons, it's saying put this row on top of this row, on top of this row, etc. You could technically do the same thing with column vectors. Put this column next to this column, next to this column, next to this column, etc. We can also transpose matrices as well. It's going to take the rows in a matrix and convert them to columns. And this idea of putting commas and semicolons to put things next to each other and stack things on top of each other is called concatenation, where we are combining a new matrix, or we're creating a new matrix by combining pre-existing matrices and vectors. And this is reiterated here, commas, semicolons. Keep in mind, we can only combine vectors and other matrices if the number of rows or columns is the same in the direction of concatenation. So every time we create something, it needs to be square or rectangular. We can't say, hey, I want values 3, 4, 5 be placed next to a column of 1, 7, 9. Like, we need to have these spaces identified and filled in as well.